Swagatam cover the mathematics classes. In the today's lesson, I am going to discuss about ordinal number and cardinal number. Two concepts. Concept one is ordinal number. The concept one. Ordinal number. And second concept is cardinal number. Now let me explain one by one. Ordinal number is defined for an element of a set. Again repeat. Ordinal number is defined for an element of a set, whereas cardinal number is defined for entire set. So let me explain one by one. Here, ordinal number means ordinal number. Number of an element. This is important. For example, I'll take, let A is equal to, you have x, y, z, 3 units, which is discrete set. Which is discrete set. Now, what is the first element in x? Is 1. Second element in the set is y, whereas third element is z. So, the order of the first element is order of x is 1. Order of y is 2, order of z is 3. Therefore, ordinal number of x is 1, ordinal number of y is 2, odd number of z is 3. So, ordinal number tells the order of the particular element. That's it. In a set. So here, denoted by order of x, where x is any element. In the above example, order of x is equal to 1, order of x is equal to 1, order of y is equal to 2, and order of z is equal to 3. This is ordinal number. Ordinal number means order of an element. Now come to cardinal number. Cardinal number. Suppose I have said a discrete set. I have discrete set. Let A is equal to, I go for A, E, I, O, U in these alphabets. How many elements are there? How many elements are there? 5 elements are there. And that 5 is called cardinal number. Cardinal number means how many number of elements are there in that set. So, cardinal number is the number of elements in a given set. Let A be the set. The set. Its cardinal number is denoted by n of A, n of A, n of A. Read as example. A is equal to A, E, I, O, U. Therefore, cardinal number of A is equal to n of A is equal to 5. Please note down. Now I am going to do some results on cardinal number of the set. Now in these, set A, set B, set C will be given. Without finding their union, we have to find cardinal number of the union of the sets. I can repeat, without finding union of the sets, we need to find cardinal number of the union of the sets. So for that, we have two derivations, one by one. Let number one, let A and B are two disjoint sets. Then n of A union B is equal to n of A plus n of B. Number two, A and B not A and B are not necessarily disjoint. Then n of A union B is equal to n of A plus n of B minus n of A intersection B. And the third one for the any three sets, A, B, C, A, B and C. N of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. These are the three very important results. Now let me prove one by one. Proof. First of all, number one, A and B disjoint cells. Disjoint cells. Let n of A is equal to P, n of B is equal to Q. That means in set A, P number of elements are there, in B, Q number of elements are there. I will take help of Venn diagram. I am not drawing any universal set here. This is equal to, say, A and this is equal to B. Let A have elements 1, 2, 3, 3 elements. Therefore, n of A is equal to A, 3. And B, let it have 2 elements. N of B is equal to 2. Now, they are not there is only common element, that means they are disjoint. So, how many elements are there? If I find A union B, okay, this small question, so I am finding A union. A and B is equal to, you have 1, 2, 3, 4, 5. So, how many elements are there in A union B? 5 elements are there. 5 is nothing but sum of number of elements of A and sum of number of elements of B. So, here, very simple, therefore, n of A union B is nothing but P plus Q are simply n of A plus n of B. Please remember this results. If A and B are disjoint sets, then the number of elements in A union B is equal to sum of number of elements in A and number of elements in B. Okay. To prove, in this case, that means A and B are not necessarily disjoint. That means they can have some common elements. Now, how diagrams look like? Proof. I am taking help of Venn diagram. When the two sets have common element, you find their intersection. What in Venn diagram? This is A and this is B. If you observe carefully, this Venn diagram have 3 parts. Part 1, this is part 2, and this is part 2. If I focus only on A, only on 1, if I focus only on 1, it is nothing but A minus B. If I focus only on second part, that is B minus A. If I focus third one, this is A intersection B. Now, the first part and the third part, they are not meeting. So, no common elements in first and the third. That means no common elements in A minus B and A intersection B. And no common elements in A minus B and A intersection B minus A and A intersection B. As well as these two are also disjoint. Therefore, my entire A union B, is divided into 3 parts. First part is A minus B, second part is A intersection B, and the third part is B minus A. So I can go and write it. In the above diagram, A minus B, A union B is divided into 3 mutually disjoint B minus A and A intersection B. Now, A union is nothing but all the parts together. To find number of elements in A union B, it is enough to add number of elements from the first one, from the second one, and from the third one. Because all these three are disjoint. Therefore, n of A union B is equal to n of A minus B plus n of A intersection B plus n of B minus B. Here, I will do a small manipulation. Here. Before doing that one, look here. If you observe carefully, the number of elements in A minus B plus number of elements in A intersection B. Again repeat, number of elements in A minus B plus number of elements in A intersection B gives you number of elements in A. Now, number of elements in B minus A plus number of elements in A intersection B gives you number of elements in B. So, I am going to do small adjustment on right hand side of the expression. Look here, what I am doing, I know this fact, I am going to use this fact here. N of A minus B plus n of A intersection B, I am writing together as one unit. Now, I will take n of B minus A. B minus A. What I do, I add n of A intersection B. So I take them also one unit. When you add, you have to subtract. Therefore, I am subtracting n of A intersection B. Now, the first one is nothing but just now I told n of A, and second is nothing but n of B, and third we have n of A intersection B. That's all. Therefore, n of A union B is equal to n of A plus n of B minus n of A intersection B. That means add number of elements in A, number of elements in B. From that total, subtract number of elements in A intersection B. Why? Because I am adding these. By adding these two circle part, I am adding A intersection B twice. I don't want that one, so I am subtracting one time. See. Please copy. I will go to third. Now, the results is for 3 sets. That means for any 3 sets, A, B, C. Number of elements in A union B union C is equal to n of A plus n of B plus n of C. Adding all the elements from all the 3 sets minus n of A intersection B, n of B intersection C, n of A intersection C. Subtracting all from 2 and finally adding n of A intersection B intersection C. So, let me prove this way. Let B union C is equal to some set X. Let B union C is set X. So my n of A union B union C will become n of A union X. So my 3 sets concept transformed into 2 sets concept. Already I have formula for this. What do you have? N of A plus n of X plus minus n of A intersection x. A intersection x. Now I replace x by B union C. So we get n of A plus n of B union C minus n of A intersection B union C. Now second term is n of B union C. I can apply two sets concept here. That I do n of A plus n of B plus n of C minus n of B intersection C. N. Now I apply distributive property for the expression which is inside the bracket. Distribution property all we know. A intersection B union C, that is A intersection B union A intersection C. A intersection B union A intersection C. Now I don't touch first the three terms, n of B, n of C minus n of B intersection C minus. This is again n of A intersection B union A intersection C. A intersection B is one set, A intersection C is another set. So I can apply n of X union Y. Again, two sets concept. How I can do n of A intersection B, n of A intersection C minus n of A intersection B intersection A intersection C. N of A intersection B plus n of A intersection C minus n of A intersection B intersection C. Now open the bracket. N of A, n of B, n of C minus n of B intersection C minus n of A intersection B minus n of A intersection C minus into minus plus. This is A intersection B intersection A intersection C. A is repeating twice. So one time is enough. So the last part will become n of A intersection B intersection C. So I have n of A plus n of B plus n of C minus n of B intersection C minus A intersection B minus n of A intersection C plus n of A intersection B intersection C. So I derive this. We can extend this results to any number of sets. If you observe carefully, to find the number of elements in A union B union C, you have to add all the number of elements in individual sets 1, 2, 3. Next, you have to subtract the number of elements in the combination of two sets. Next one, you have to add number of elements in all the three sets, common elements. In higher classes, you may deal with more than 4 sets or 5 sets. So in the case of 4 sets, how the statement goes? How to find number of elements in for A, B, C, D, 4 sets. I want to find number of elements in A union, B union, C union, D. 4 at a time. As per my first principle, first I add number of elements in of the. I take number of elements in each set, I add all of them. Then I take all the combinations of two sets all the combination of two sets and I take their intersection, then I take the number of elements in those common and I subtract all. That means take n of A intersection B minus n of A intersection C minus n of A intersection D minus n of B intersection C minus n of B intersection D minus n of C intersection D. How many are? 1, 2, 3, 4, 5, 6. All are. Then I take combination of 3. Combination of 3. N of A intersection B intersection C plus n of A intersection B intersection D. Number of n of A B intersection C intersection D. Number of A intersection C intersection E. And finally, I need to subtract number of elements which are common to all the sets. Now I can extend this to 5 sets, 6 sets and so on. Any number of sets we can extend this sequence.